there's a few rules that we follow. The first rule is we always start reading from left to right. Second rule, move, starting on the very left-hand side of the number, move to the right until you get to your first non-zero value. Any zeros that you pass along the way are considered non-significant. Once you hit that first digit, that is your first significant figure. Count that digit and every digit to its right as significant. Now zeros have some difficulty associated with those. Captive zeros, which I'll show you what those are significant. But if there are trailing zeros, those have different rules depending on the number. So we will discuss that on the next slide. So let's look at 3 different examples. Let's take the number 300.1. So we start at the left and we move to the right until we see the first non-zero digit. Well, here 3 is a non-zero digit. It has to be our first significant figure. We move on. We have zeros here. These are considered captive zeros. They are in between, reading from left to right, 2 digits that are non-zero. So captive zeros count as significant figures. So reading from left to right, there's 1, 2, 3, 4. This number would have 4 significant figures. Let's look at this 0.002 number. Starting at the very left, moving all the way to the right until we see our first non-zero digit and count that as our first significant digit. So this 0 is not significant, this is not significant, not significant. The 2 is the only significant value that is present in this number. So 0.002 only has 1 significant figure. And our last example, 005406. Starting at the far left, moving until we get to the first non-zero digit. These zeros do not count. They're called leading zeros. They don't count as significant. The 5 is a significant value. Moving on from there, the 4 is significant. This 0 is significant because it's between 2 non-zero digits, and then the 6 is significant. So 005406 has 4 significant figures. Now I told you before that complications arise when we have trailing zeros. So what would happen if I had a 0 trailing after this 2, a 0 trailing after this 6? There are 2 different rules that we have to abide by, and we're going to cover that on the next slide. So let's get to it. If there is no decimal point and we have trailing zeros, there's a rule for that. And if there is a decimal point and we have trailing zeros, there's a different rule used for those types of numbers. So let's look at the rules. How would we assign which numbers are significant in 300? These are not captive zeros, they're trailing zeros. Are they significant or are they not significant? And we know that leading zeros are not significant, but what about these zeros over here, these trailing zeros? Are they significant or not? So the rules that we abide by in chemistry are, if there is not a decimal point, trailing zeros do not count as significant. So let's look at that 300. There is no decimal point present. So these zeros are not considered significant. So 300 by itself without a decimal point will only have 1 significant figure. The second rule, if there is a decimal point, trailing zeros count as significant numbers. So here we know that leading zeros are not, but these trailing zeros, since there is a decimal point here, are significant. So 0.04800 has 4 significant figures. Okay. Those are our rules. Those are our foundations for significant figures. Let's start adding and subtracting and multiplying, dividing, and see what rules are followed by them. What rules we follow there. So for addition and subtraction, there are different rules than for multiplication and division. So the rule for addition and subtraction, we don't care about the total number of significant figures when we're adding or subtracting. We are only concerned with the total number of decimal points in each of the numbers. And our final resulting number, when we add or subtract 2 numbers, has to have the same number of decimal points as the previous numbers that have the least number of decimal points. So let's take an example. 83.5 milliliters and 23.38 milliliters. This 83.5 has 3 significant figures, but we're adding, so we don't really care. I'm just explaining a little bit more. The 23.38 has 4 significant figures, but we don't really care. What we are concerned with is this 83.5 has 1 decimal point, and this 23.38 has 2 decimal points. So when we add these 2 numbers together, our final answer can only have the least number of decimal points, which comes from this. There's only one decimal point here. Our final value has to have one decimal point. So if we add these, we get a number of 106.88 milliliters. In this case, this 8 over here is not significant because we can only contain one, we can only keep one decimal point. So we have to do something to this. On the next slide, I'm going to tell you about the rounding rules, but for right now, it's going to follow traditional rounding rules, and we're going to round this 8 up to a 9. And we're going to get 106.9 milliliters. Now let's see the rule for multiplication and division. The answer, the final answer, will contain the same number of total significant figures as the value of the previous numbers that have the least number of significant figures. That might be a little confusing, so let's look at an example. Let's take the volume. We're going to multiply three numbers together. Each one has a different number of significant figures. 9.2 centimeters has two significant figures. 6.80 centimeters has three significant figures. 0.3744 centimeters has four significant figures. So from this point, when we multiply these three numbers together, the final answer can only contain the same amount of significant figures as the least significant figures present here, which has to be this 9.2. There are only two present here. So our final answer can only contain two significant figures. If we put this into a calculator and we can calculate out 23.4225 cubic centimeters. But this is not the correct answer. We can only keep two significant figures. So this 2 and this 3, we can keep. These digits are significant. So now we have to get rid of these. So we're going to use traditional rounding rules. This number is less than 5, so we're not going to do anything to this 3. We're going to end up with 23 cubic centimeters. So those are our two rules. We're gonna for addition and subtraction, we keep the least amount of decimal points. For the multiplication and division, we keep the least amount of total significant figures.